Hi, welcome back to the Calculus 1 lecture series, and we are in the unit number 3, application of differentiations, and we are in the second part of the lecture number 21. We are talking about the L'Hopital's rules, and for the first, for the first video, we talk about the typical classical L'Hopital's rule. So if you have the situations like 0 over 0 or infinity over infinity for those indeterminate forms, then how can we apply the L'Hopital's rule? So our second video going to talk about is how about if we have a different type of the indeterminate form, then what type of the transformation maybe we can do, and then we'll be able to apply the L'Hopital's rule. Okay, so now let's go ahead and go to our lecture notes. And let's start. Okay, from the video 1, we stop at the, we did the indeterminate form, so we did the regular, like the L'Hopital's rule, and then we stop at here. We say, how about we have those few, the indeterminate form. So for example, so here we have infinity times 0. So we don't know what is that. It's indeterminate. The infinity minus infinity, 0 to the 0 power, 1 to the infinity, and infinity to the 0 powers here. All right. So for this situation, what can we do in order to make it work? Okay, so remember, right? So the, for the typical L'Hopital's rule is if we have a 0 over 0 over infinities, right? So if you have this situation, then what we can do, we can take the derivative on the numerator and take the derivative on the denominator first, separately, and then to see limit exists or not after you take the derivatives, right? So now how about if I have the 0 times infinity? So what I can do here, okay, so the way we can do is here, so if you have the 0 times infinity, so we can rewrite. Okay, so we can rewrite as you change the form. You can say it's 1 over f of x is 1 over gx, right? Or you can rewrite as the gx over 1 over f of x. So for this situation, so basically you change this one to the 0, 0 or infinity over infinity. And then you can apply the classical L'Hopital's rule, just take the derivative on the denominator and take the derivative on the numerator, and then apply the limit again, right? Okay, so now how about if I have infinity minus infinities here, right? So in here, for these ones here, what you need to do is here, so still our strategy is we're going to rewrite this f of x minus gx, okay? And so what is in here we need to do? We need to combine those two terms. So we need to use algebra. Okay, so we need to use the algebra identities here to combine it. So to combine and make it become 0 over 0 or infinity over infinity here. All right, so that is the second part here. So how about to me, I personally feel like sometimes the infinity minus infinity is the is the toughest ones here to do. Okay, so now what is like these three situations here, right? 0 over 0, 1 over infinity, and then also like the the infinity over 0. So for these three, what can we do here? Okay, so in here for these three situations, so the way we typical will do, we said the letter y, right? So it's always the powers, right? So we said f of x gx. And then what you do here, you take a look at you take the natural log of y, both sides. And because you take a natural log of y, both sides, so the natural log have this good property. So the gx can be moved to the front, and this is the natural log f of x here. Okay, and then in here, see here, so then you will be able to evaluate. Okay, so then this is a step number 1 and the step number 2. Then you'll be able to evaluate this limit x approach to a, then the gx and the natural of f of x. Okay, and you can use these ones here, and then you're using the L'Hopital's rule to do it. So you might need to, like transfer again, become like 0 over infinity over infinities, right? Okay, so now the third step is here. We need to be very careful here. If the limit does exist, okay, so if the limit x approach to a, and this function gx natural log f of x does exist here, and then don't forget, because what this is the natural log y, right? So what you need to do, you need to convert it back. So then the limit x approach to a, the f of x gx, because you took the natural log to get a L, so what is the final limit will be? You need to e back, right? So that's why you have to e to exponential L's here, right? Okay, so that's why here you be careful. So the last step is, you need to be very careful about it. Okay, so now let's take a look, right? So these are the basic fundamental rules. And now let's try. Okay, so here, the first thing here is limit x approach to 0 cotangent. So of course, that always we plug in. So x approach to 0 is x is 0, right? So cotangent 0 is what? Is infinity. So you say, oh, okay, so this is, so this is the 0 to the infinity situation here, right? So this is a 0 to the infinity situation. Then I need to flip one of them. So in here, I can do this, right? So I can say here, so this is the limit x approach to 0. So this is the x. So cotangent, right? So I can flip it. So this one's here, you can change it. This is 1 over cotangent, right? So 1 over cotangent is what? It's a tangent, right? So here, so this is 1 over what? So this will be 1 over tangent here. Okay, so now you plug in the 0, 0 again, right? So now you plug in the 0, 0. So this will be 0, and this will be zeros, right? So now this one here will be 0 over 0 situation. And then you, okay, also you can do here, you can say this is the limit x approach to 0, this is x. So this one you can change, this will be what is a cosine x and a sine x. And then this one you say, okay, this is x approach to 0, x sine x, and this is the limit cosine x here. All right, so what you got here, so now you have here, remember this one's here, right? So this one's here, we know this is 1 because you use L'Hopital's rule, and the limit cosine equal to 0. So what is this one's here? This one is 1 also, correct? So this is x approach to 0. So the final answer here is 1 here. All right, now let's take a look at this one. The second one's here. The second one, we said limit x approach to 0, 1 over x fourth minus 1 over x squared. So this is 1 over 0 minus 1 over 0. So it's similar like to the infinity minus infinities, right? So we said infinity minus infinity is, is not, it's indeterminate. So what do we need to do? We need to do some algebra combination. All right, so let's see here. So x approach to 0. All right, so this is the two things. So I find a common denominator. So if I find a common denominator, so here will be x fourth. So what is here? This is will be 1 minus what? X squared. All right, so now let's try again to see what we have. So when x approach to 0, what is the top going to approach to? Will approach to 1, right? So when x approach to 0, what is the bottom going to approach to? Approach to 0. So it will be 1 over 0. So what is this final answers here? This one is a determinant, right? Because when the denominator get very, very small, it will become infinity. And the numerator is a constant. So that's why it's become the infinity here. All right, so now let's take a look here. Let's take a look at number, okay, part C here, right? Let's see. Right, so part C here. So limit x approach to infinity and 1 over x squared minus 1. So the infinity, that means this number approach where? Infinity. And x minus 1, this number what? This number approach to infinity, right? And when the both numbers, like approach to infinity, but this one here is in the denominator. So when the denominator approach to infinity, what is this term going to approach to? Going to approach to 0, right? And this one also is in the denominator approach to infinity. What is this term going to approach to? So it's going to approach to 0. So this limit is 0 minus 0. So 0 minus 0 is a determinant or indeterminate. It will be determinant because 0 minus 0 is zeros here, right? Okay, so it's a 0 here. Okay, now let's do D here. Okay, so D is x approach to, all right, so x approach to 0. So this term going to approach to 0, right? So then the x approach to 0, e to the 0, this one is approach to 1. So 1 minus 1 approach to 0. And because 1 minus 1 approach to 0, so both these terms here approach to infinity, and then this term will going to approach to what is infinity. So we will have infinity minus infinity. So for the infinity minus infinity is the determinant or indeterminate. It is indeterminate. So, okay, so we have infinity minus infinity. So what do we need to do? Let's combine, right? So here is a limit, x approach to 0. Now, how do we combine the common denominator? So this is x, I need to combine the two fractions, right? So I need to find a common denominator. So it's x times ex minus 1. Okay, so for the first fraction, what do we have? We have ex minus 1. Now, what happened to the second ones here? So we will have x here, right? So that's how do we combine. Now let's take a look. What do we have here? All right, so the x approach to 0. So this is approach to 0. This term is approach to 0. So the whole denominator approach to 0. And now the top ones here, this is approach to what? This is approach to 1, this approach to 0. So it's 1 minus 1 minus 0. So top is what? It's 0, right? Okay, so you see, oh, wow, I have a 0 over 0. So you say, how do I do that? You say, okay, I can use the L'Hopital's rule. Remember the L'Hopital's rule, you can take the derivative if you have the form is 0 over 0, infinity over infinities, right? Okay, so now let's use the L'Hopital's rule. So this is when we use the L'Hopital's rule here. Okay, let's take a look at the derivative. So EX is by itself is EX, correct? Okay, so this is a -1, right? Because this one is becomes 0, so X derivative is 1. Okay, so now the second one here is the product rule, right? So I can use the product rule. So X, so this will be the EX -1. Then plus X, then the derivative of EX -1 still is EX. Okay. Okay, so now let's see here what we have here. All right, so X approach to 0, so this is approach to 1. So what is this one approach to? It's approach to 0. Okay, X approach to 0, this term approach to 0, this term approach to 1. So 1 minus 1 plus 0, oh my gosh, it's 0 over 0 again. So what I need to do, I need to use the what? L'Hopital's rule one more time. Remember, we can continuously use L'Hopital's rules till we get our answers, right? Okay, so now let's take a look at this one. Now take the derivative on top. What do we have? EX. All right, so take the derivative on the bottom. So this is EX, and this is 1, disappear. Then plus the product rule, XEX. So take the derivative of X, hold the EX here. Then plus hold the X, take the derivative of the EX. Okay, okay, now let's try again to see we need to do the L'Hopital's rule again. X approach to 0, what is this one approach to? This one approach to 1. X approach to 0, what is this one approach to? Approach to 1. This one approach to what? Approach to 1. What happened to here? This approach to where? Approach to 0, right? So finally we got our result is what? Is 1/2 here, right? So this problem is interesting because you need to do the L'Hopital's rule how many times? Twice, right? And first you need to combine that as well. Okay, now let's take a look at part E here. All right, take a look at the part E to see what do we have here. Okay, X approach to 0. So this one here is going to approach to what? Approach to 0, right? So X approach to 0 here. So this the whole thing, this one is approach to infinity, right? Then the cotangent approach to 0 is infinity, and the exit here. So infinity over 0, the whole thing will approach to what is infinity. Right? We said the infinity over 0, the whole thing will approach to infinity. So then the final things here, you will have infinity minus infinity. So you say, oh, this is another those infinity minus infinity things. All right, so what we can do here? Let's combine the common denominator, right? So this is x sine square x. Right, so the first term we have what? This is x minus what here? Minus sine square x and what? Cotangent x, right? So the cotangent x. Let's simplify a little bit. What is the cotangent here? So this is a sine x square times cotangent is cosine x sine x, correct? And I can cancel one sine here. All right, so now I can simplify this one because we are more familiar with sine and cosine. So I like to get rid of cotangent here. So this is x. Here this is x minus. So this term simplified to the what? Sine x cosine x, and this is x sine square, what? X here. Okay, now let's check. x approach to 0, this is approach to 0, this is approach to 0 because sine x equal to 0, right? Then here the whole bottom is approach to 0. Oh, wow, we have the form of the 0 approach 0 over 0. Then what can we do? We can apply the L'Hopital's rule. We can take the derivative on the numerator and on the denominator, right? Okay, let's take the derivative. So x is what? It's 1. So what do we need to do here? This will be, we need to use the product rule. So take a derivative of the sine. So what is the derivative of sine? It's cosine. So cosine times cosine is cosine square. Then hold the sine, right? Take the derivative of cosine. Cosine is a negative sign. Then you have a negative sign in front, so it's a sine square. Then the bottom here, the bottom you can have, so that you can use the product rule. So the take the derivative of x, so it's a sine square x. Then plus this is 2 sine x. Then chain rule will give you the cosine x here. All right. Okay. So now in here, you take a look here, right? So let's try to simplify it a little bit. So in here, okay, so the top here, 1 minus cosine square, we use trig identity, right? So this is a what? This is a sine square, right? Because the trig Pythagorean theory for the trigs, right? So it's a sine square plus cosine square is equal to 1. So 1 minus cosine square equal to sine square. So this one give you the 2 sine square x. All right. Okay, so now in here, let's see here. So it's x approach to 0. So this is a 2 sine square x. Then the bottom, you can what? You can, you can factor the sine, you can factor the sine x out. So you have a sine x plus 2 cosine x's, right? Okay, so that's pretty good. Now you see, this sine x, I can cancel out 1. So the top will be 2 sine x. Now let's try again. When the x approach to 0, what is the top one approach to? The top one approach to 0. And this one approach to 0. But what is the cosine going to approach to? It's 1, right? So this one approach to 2. So your final answer is 0 over 2. What is 0 over 2? It's zeros here, right? Okay. All right, now let's take a look at part F here. The part F is limit x approach to 0, cosecant x to the x squared. So I know, let's check. So this one is 0. So cosecant x is what? Is infinity. So this one is give us the infinity to the 0 power. So we know this is indeterminate form. So let's take a look at the, so let's, so now let's say let y is equal to the cosecant x to the x. Now let's take a look at natural log y. So this is x natural log cosecant x. Okay, now let's try again to see what we have here. So here x approach to 0. So this one is zeros, right? So this one's here, cosecant x. Cosecant x approach to 0. This is approach to what? Approach to infinity. If this one approach to infinity, then what is the natural log of infinity going to approach to? Approach to infinity. So this one will give us the final form is 0 times infinity here. Okay, so the 0 times infinity. Now we say, well, in order to try to find the limit, what do we need to do? So we say we need to flip it. So Typical, I don't like to flip the 1 over natural log on the bottom, so I will leave the natural log cosecant x here. Then I will flip the 1 over x to the bottom here. Okay, and now let's try to check again, right? So the 1 over x approach to 0. So if this is approach to 0, then what is the 1 over x approach to? 1 over x approach to infinity. Then the same thing, this one is approach to infinity here, right? So now what can I do? Okay, so the limit x approach to 0. And so this is 1 over x and the natural log of cosecant x. Then what I can do here, because I have infinity over infinity, so I can use L'Hopital's rule. Okay, the derivative on the 1 over x is x to the -1, so it's a -1 times x to the -2, right? So it's 1 over x squared, okay? And the natural log, so is a cosecant x, and then the top of the chain rule will be what? Will be negative cosecant x and what? And the cotangent x, right? So that's the derivative of the cosecant. Okay, so now let's see here. Okay, so let's okay, so this negative and this negative disappear. So this one will be, so don't forget I have limit. Okay, so it's a limit x approach to 0. And then the cosecant, and so we can kind of cancel this, right? So this is a limit and cotangent x time, you flip the x squared, so this is what? X squared. And then the limit x approach to 0, cotangent is cosine x over sine what? Over sine x, and this is x squared. Okay, so now I can separate this one, so the sine x over x and x and cosine x. Now let's see what is the limit going to be. We know the x over sine x, what is this one? This is going to approach to 1, and the cosine 0 is 1, and the x equal to 0 is what? It's 0 here, right? So the whole limit is going to approach to what? Approach to 0. Don't forget, we have a natural log, so we need to what? We need to e back. So my final answer here is limit x approach to 0, and I e back. This is cosecant x to the x. What will be? It's e to the 0. So I'm going to approach to 1 here. Okay. Now let's take a look at the last problem. So this is x approach to 0. So for this problem here, right? So let's check. So this is 0. So you will have 0 over 0. So this is indeterminate. So it's just like we did before. We say x over the x power is y. Now let's take a natural log both sides. So natural log y is equal to the x natural log x. Correct? Okay, now let's check again, see what do we have here. So x approach to 0. So this is approach to what? This is approach to 0. So x approach to 0 here. Then what is the natural log going to approach to? So this whole thing, right? What is this whole thing going to approach to? This whole thing going to approach to the negative infinity, correct? Okay, so doesn't matter this negative sign, so I still have 0 times infinity. So what I need to do here, I say, okay, now because of this, I need to flip it. I need to flip 1. So this is 1 over x. So we do the same thing. This is 1 over x. I flip the x one, it's easier. Okay, so now the limit x approach to 0, x the natural log x, it will be limit x approach to 0, I flip it, right? Natural log x, 1 over x. So let's check again. So what is here? This term going to approach to the negative infinity. Then this is x equal to approach to 0. So the bottom going to approach to the infinity also. So we still have the infinity over infinities, indeterminate form. So what do we need to do? We can apply the L'Hopital's rule now, right? So we say I can apply the L'Hopital's rule. So I will have limit x approach to 0. So natural log, what is the derivative of natural log? Is 1 over x. So 1 over x here, you can rewrite like x to the negative 1, right? Then you use the power rule. What is here? So this is negative 1, x to the what? Negative 2, right? So then here, let's see. This is x approach to 0. This is 1 over x. So this is negative 1 over x squared. Flip it, okay? All right, so you flip it, and then this one you can cancel 1. All right, so I only have what? Limit x approach to 0 to the negative x. So what is here is 0. All right, don't forget. One more time, what here? Because y, we took the natural log of y. So what you need to do? You need to log it to the back, right? So I know the limit x approach to 0, x to the x is equal to e to the what? E to the 0 is back, right? You need to log back. So don't forget the reason why this is here is because here, right? And because you took the natural log y on both sides here. Okay, that's it. That is the L'Hopital's rule. So the key things for you to remember is when you be able to use the L'Hopital's rule, you will have the indeterminate form 0 over 0 over infinity over infinity. So those are the one you can just apply the L'Hopital's rule by take the derivative on the denominator and take the derivative on the numerator. Right? How about if you have the other indeterminate forms? So what you need to do is you just need to find some type of the transformation or some type of the algebra combination, right? And then you will change the form to the 0 over 0 and the infinity over infinity. Then you can apply the L'Hopital's rules. Okay, so as you can see, it's a very, very handy rules, right? Try to find the limits. All right, that's it. And so looking forward to talk to you on our next topic here. Okay, bye.